Many people have noticed that when they try to wash oily hands with water alone, the oil simply refuses to come off. Similarly, images of oil spills in the ocean often show a distinct layer of oil floating on top of the water, never mixing together. These everyday experiences raise an intriguing question: why can't oil dissolve in water? Although both substances are liquids, they behave very differently when combined. Understanding the reason behind this phenomenon can help explain not only household challenges, but also environmental issues. Let's explore the science that keeps oil and water apart. Molecules are the fundamental building blocks of all substances. Each molecule is made up of atoms bonded together in specific arrangements, giving different materials their unique properties. When substances mix, the interactions between their molecules play a crucial role in determining how well they combine. For example, oil and water do not mix easily because their molecules have very different characteristics. Water molecules are polar, meaning they have regions with slight electrical charges, while oil molecules are nonpolar and lack these charges. This difference causes water molecules to attract each other and exclude oil molecules, resulting in the familiar separation of oil and water. Understanding these molecular interactions helps explain why some substances blend seamlessly, while others remain distinct. Oil and water are two liquids that do not mix easily, and their behavior when combined is influenced by differences in molecular density. Water molecules are packed more closely together, resulting in a higher density compared to oil. This means that for the same volume, water contains more molecules than oil does. As a result, water is heavier per unit volume and sinks below oil when the two are placed together. Oil, with its fewer molecules per volume, is less dense and therefore floats on top of water. This fundamental difference in molecular arrangement explains the distinct layering that occurs when oil and water are combined. Water molecules are known for their strong ability to bond with each other through hydrogen bonds. These bonds occur because water molecules have a polar structure, with a slight positive charge on one end and a slight negative charge on the other. As a result, water molecules are attracted to each other, forming a tightly connected network. In contrast, oil molecules are nonpolar and lack this charge separation. Without polarity, oil molecules do not form strong bonds with each other or with water. This fundamental difference in molecular bonding causes water and oil to separate when mixed, with water molecules clustering together and oil molecules forming their own distinct layer. Polarity and electronegativity are key concepts in understanding why certain substances mix while others do not. Water molecules are polar, meaning they have a partial positive charge on one end and a partial negative charge on the other. This arises because oxygen is more electronegative than hydrogen, pulling shared electrons closer and creating an uneven distribution of charge. In contrast, oil molecules are nonpolar, with their electrons shared more equally and no distinct charge separation. Because polar molecules like water are attracted to each other, and nonpolar molecules like oil prefer their own kind, the two substances do not mix. The difference in polarity creates a barrier, keeping water and oil separate even when combined. The principle of like dissolves like helps explain how substances interact with one another. Polar molecules, which have regions of positive and negative charge, tend to dissolve in polar solvents because their charges can attract and interact with each other. Water is a classic example of a polar solvent, making it effective at dissolving other polar substances. In contrast, nonpolar molecules lack distinct charged regions and therefore dissolve best in nonpolar solvents, where similar molecular structures allow them to mix freely. Oil is a nonpolar substance, while water is polar, so their molecules do not interact in a way that allows them to blend together. As a result, oil remains separate from water, forming distinct layers when combined. Detergents and soaps play a crucial role in cleaning by addressing the challenge posed by the natural separation of oil and water. Oil molecules tend to repel water, making it difficult for water alone to remove oily substances from surfaces. Soaps and detergents contain special molecules called surfactants, which have two distinct ends, one that is attracted to water and another that binds to oil. When applied, these surfactants surround oil particles, breaking them up and allowing them to mix with water. This process, known as emulsification, enables the oil to be lifted away and rinsed off easily. As a result, surfaces are left clean and free from oily residues. Birds possess a remarkable adaptation that helps them stay dry even in wet environments. They produce a special oil from a gland located near the base of their tail, which they spread over their feathers during preening. This oil creates a waterproof barrier, preventing water from soaking into their plumage. As a result, birds can swim, dive, and fly in the rain without becoming waterlogged. The effectiveness of this natural oil highlights its practical importance, demonstrating how its unique properties are essential for survival. Through this process, birds maintain their insulation and buoyancy, showcasing nature's ingenuity in using oil for protection. Ducks are well known for their ability to stay dry even in wet conditions. This remarkable trait is due to the oil produced by a gland near the base of their tail, which they spread over their feathers during preening. The oil creates a waterproof barrier, allowing water to bead off and keeping the duck warm and buoyant. In contrast, chickens lack this specialized oil gland, so their feathers absorb water easily and become soaked when exposed to rain. This difference highlights how oil production is a crucial adaptation for some birds, enabling them to thrive in aquatic environments. The presence or absence of oily feathers illustrates the diverse strategies animals use to cope with their habitats. In summary, oil cannot dissolve in water primarily due to two key factors: molecular density and polarity. Oil molecules are less dense than water and possess nonpolar characteristics, while water molecules are polar. This fundamental difference prevents them from mixing, resulting in oil floating on water rather than dissolving. These properties have significant implications in daily life, influencing everything from cooking and cleaning to environmental phenomena like oil spills. Understanding why oil and water do not mix helps explain many natural processes and guides practical solutions in various industries.